Okay, we've seen how we can, simplify a radical. We know how we can break it down a little bit. The next thing we want to do is just look at one way that we're going to be able to combine radicals or roots, and that way is going to be with multiplying. And multiplying is generally the easiest thing that we can do. Now, I just want to point out that we don't know what the square root of 8 is, and we don't know what the square root of 2 is, right? But I do want to point out, let's look at another example. What if we did something like the square root of 4 times the square root of 9? Well, the square root of 4 is, of course, 2. The square root of 9 is, of course, 3. And 2 times 3 is 6. Is there another way we could have gotten this answer rather than just simplifying each one? We could. If we actually multiply the insides of the roots, 4 times 9, 4 times 9 is actually 36, and the square root of 36 is 6. See how we get the same answer? So it is a rule that we can multiply the insides of square roots together. And so we don't know what the square root of 8 is, we don't know what the square root of 2 is, but we know that we can multiply them together, the insides. 8 times 2 is 16, and the square root of 16, we do know what that is. So the square root of 8 times the square root of 2 is actually 4. That's what it works out to be. Here, again, we can multiply these together inside. This becomes the square root of 20. Do we know what the square root of 20 is? We do not. But is there a way that we can break this up that will allow us to simplify it? There is. Let's break it into 4 and 5. I want to split it into two numbers, one of which I know the square root of. I know the square root of 4. That's why I picked it. Square root of 4 is 2. That's simplified. Let's mix in some variables here. Square root of 5x times the square root of 20x. If I multiply these together, 5x times 20x. 5 times 20 is 100. X times x is x squared. Now I know that I could do the square root of each one of these separately. Square root of 100 is 10. Square root of x squared, remember what we're doing here is just dividing the power by 2. It's 10x. Another one here, let's multiply these together. 12y to the third times 3y to the fifth. 12 times 3 is 36. Y to the third, y to the fifth is y to the eighth. We're adding those powers together. And of course, the square root of 36, the square root of y to the eighth. I'm going to write it over here. Square root of 36 is 6. The square root of y to the eighth is y to the fourth. Now, square root of 7 times the square root of 7, well, 7 times 7 is 49. So I can multiply them together, keep the square root there, but the square root of 49 is just 7. That's funny. Square root of 7 times the square root of 7 is 7. Square root of 3 times the square root of 3, this is the square root of 3 times 3, which is 9, right? Square root of 9. And the square root of 9 is 3. See what's going on there? Square root of 11 times the square root of 11. Can you guess what the answer is going to be? Well, let me do this the long way. 11 times 11 is 121. And the square root of 121 is 11. So hopefully you see the pattern there. And maybe you could even just right away say what this is going to be. Square root of x times the square root of x. Well, put them together. That's x squared. And the square root of x squared is just x, right? X to the 1. But I'll just put x. So take a look at a couple of these on your own. I will do one more. How about this one down here? Let's see. I want to multiply these together, put them under the same square root, x to the fourth times 8x to the fourth. 5 times 8 is 40. X to the fourth makes x to the eighth. Now, when you have a number here in front of the variable, I want to break this off separately and give the number in a variable its own root. Now, 40, how can we break that up in a helpful way? How about 4 and 10? Because the square root of 4 is 2, I'll leave the square root of 10 as it is. It does not simplify anymore. Square root of x to the eighth is x to the fourth. And typically we write the square root at the end of the term. Okay, so again, when you have numbers and letters or variables mixed, break them into separate square roots. Let's look at this one again. Here I'm going to combine these 10n times 5n. That makes 50n squared. Now let me look at 50 separately and n squared separately. How can we break up 50 in a helpful way? How about 25 and 2? Square root of 25 is 5. That's why I made that. Square root of n squared is just n. And again, I'm going to write it like this. Okay, try a couple of these that I've left blank. I'll check the completed notes for those. Now something a little bit, add another dimension to this. A lot of our numbers, our roots, when we simplify them, they look like this. A number and then a square root, a number and a square root. What if we take some of those results and then multiply them together? How do we multiply them together? Well, we've seen that we can actually multiply the numbers inside the roots together, like 5 times 5. And we can also multiply the numbers that are in front, 3 times 4. So I'm going to make that, I'm just going to write it like this. So I can multiply these numbers, and I can also multiply the numbers inside there. So only multiplying them by what I can multiply them by. Let's see, 3 times 4 is 12. And then this becomes 25 inside here. Now this is a little bit weird, because I know the square root of 25 is 5, right? But what am I going to do? Am I just going to write it like that? No, you gotta understand that there's an invisible multiplication sign here. And 12 times 5 is 60. So the result of multiplying these together is 60. Let's look here. Again, I can multiply the numbers on the outside together, 3 times 2. I can multiply the roots together, 50 times 2. Let me multiply those together. 3 times 2 is 6. 50 times 2 is 100. And the square root of 100 is 10. So I'm going to put times 10. 6 times 10 is, hey, it's 60 again. Let's do another one here. Again, I could do 5 times 3 times, and then 10 times 2. 5 times 3 is 15. And this becomes square root of 20. I don't know what the square root of 20 is exactly, but I do know that I can break it into 2 separate roots. I can break it into 4 and 5. I like to pick 4 and 5 because I know the square root of 4. So again, I'm always looking for 2 numbers I can split it into, one of which I know the square root of. And what is the square root of 4? Well, it's 2. 15 times 2, these numbers on the outside, I can multiply numbers on the outside of a root. Okay, this is a little bit weird of a process, but take it step by step. It's a multi-step problem, but we want to get into a very simple form. We want the number inside the root to be small too. Same thing here, let's do 6 times 2, and then, square root of 8 times 6, multiplying those numbers inside there. 6 times 2 is 12, and then under here we get 48, 8 times 6. Now 48 can split up into a couple numbers, 4 and 12, but the best numbers to choose is 16 and 3. If I do the square root of 16, that's 4. And 12 times 4, these numbers on the outside, I can multiply 48 root 3. I will leave these ones here for you. Now these ones here, you'll notice that, we got a number on the outside of parentheses. We know that whenever we do this, we want to multiply these together, right? Distributing here. I'm going to write it out a little bit. This becomes 4 root 2 times 2 root 2, right? I should multiply this to this. Plus, I'm going to multiply the 4 root 2 times the square root of 18 also. So now I just have, a bit more work to do. Let's see, these numbers on the outside, I can multiply them together. 8 Square root of 2 times the square root of 2, I can make this into square root of 4. Plus, okay, the 4, it doesn't have a number to multiply on the outside here. So I'm just going to leave it as 4. 2 times 18, though, inside the roots, 2 times 18 is 36. And hey, I know what these square roots are. This one is 2, and the square root of 36 is 6. What do we have? 8 times 2 is 16. 4 times 6 is 24. 16 plus 24 is 40. Step by step, one by one, all right? Let's do this again. 3 root x, 5 root x. So 3 square root of x times 5 square root of x. That's the first distribution. Plus, and now 3 square root of x times, oh, it's the same thing, 5 square root of x. Let's see here. 3 times 5 is 15. Multiply the roots together, that's the square root of x squared. X times x is x squared. 3 times 5 is 15. X times x is x squared. And we know that the square root of x squared, remember, we're just dividing that power by 2. It's just x. The square root drops off. It's just x now. That's what the square root generally does. It shrinks something down. And here, 15x again. That's an x. Hey, 15x, 15x. These are like terms. But we're being just adding, right? 30x. Here, again, I want to distribute here. The 3 root 3, I'm multiplying it by the 2 root 5, minus the 3 root 3 times the 2 root 7. Multiply the numbers on the outside. 3 times 2 is 6. 3 times 5 is 15 inside. Minus 3 times 2 is 6. 3 times 7 is 21. Now here, unfortunately, it doesn't really look like they're like terms in the same way that these ones were, especially because there's, no x's here. In fact, we're actually finished here. You might wonder, can we subtract the numbers inside the roots, or can we subtract the 6's? We cannot. In a way, we look at these like as if they were like terms. Go ahead. And since they don't have the same square root, I'm going to say that they are not like terms, and I can't combine them. It's just, we're just going to leave it as it is. We'll do the same thing here. We have, okay, this is being distributed through there. Square root of x times 5 root x. Plus square root of x, we're distributing through, times 3 root 2. If we multiply what's in the roots, we get 5 root x squared, plus, here we have 3 into x. Now I want to point out here, we know that the square root of x squared is just x. But here it's 2x. First of all, we don't know the square root of 2, and it won't split into any other numbers. And this x doesn't really have a power, any significant power, so we can't simplify it. It's just going to leave it as it is. And so again, this has a square root. These are being added, but this has a square root. These are not like terms. We are going to leave it like that.